My name's Eric Carter. I am on the marketing team at Hedvig. Hedvig is a small startup in the software-defined storage space. We ship only software, no appliances today. And you'll get our point of view as I unravel here. But what I'm really going to try to do is not necessarily talk Hedvig feature, function, and all that, but you'll sort of get it as it unravels. I tried to pick a provocative title in the sense that I wanted to point out just what everyone has been pointing out, that there is this page from the playbook of the Googles, of the Amazons, of the Facebooks that have impacted how storage is being done and built, whether it's an appliance form factor today or whether it's software like Hedvig does. So we'll talk through some of that today in the time that I have allotted here, just to give you an idea how some of this stuff works and what's happening in the space. Now, I'm going to start out my presentation just with a little bit. I have a friend here, another Chris, who he and I used to do presentations together when we were at Riverbed. And we would always start in the city, whatever city we were in, by trying to kind of point out some stories about the town and whatnot. Now, I have some stories after last night. Chris and I were out drinking on 6th Street and went to barbecue and all that kind of stuff. So I'm a little slower today than I should be. Austin's a great town, and we're going to enjoy it again tonight, I think. So one of the things I like to do is to kind of point out a little bit of who lives in this town. And anyone recognize? Now, I've sort of created a monster here from this, and I started looking around, and there were some people that I was like afraid to put on the slide, and I'll mention them in a second. But I didn't know that Robert Plant lived here for a while. Yeah, but he's moved. I think he moved. At least the internet said he moved. Sandy Bullock lived here, right? She moved, I think, after the divorce or whatever happened. I guess Carl Rove lives here. I didn't want to put him on my slide. I'm trying to think. There was one other I had. Oh, the biking guy. What's his name? Lance. Again, controversial. Anyone? Here's what I'm going to unravel. So also these two gentlemen, who I actually admire to some large degree, I guess also have homes here. They weren't necessarily bored. So we have all right, our man on the right-hand side there, as well as Dan Rather. So two gentlemen from town. I didn't know. So I always like to learn a little bit about what's going on in the towns where I visit. I got that right? They both still live here? Yeah, okay. Yeah. Cool. So Webscale IT, what's going on here? So there's all of these companies that by necessity have built data centers and built systems and built applications in a different way than we've been used to doing it from an enterprise perspective. They've done it for various reasons. Some reasons are simply cost. They couldn't afford to roll in an EMC array at the rate that they were growing their data. And so they had to find a different way to sort of skin the cat, so to speak. The databases they were using weren't going to scale, so they went out and wrote some of their own. So there was a lot of these sort of systems and innovations that they've driven in their own data centers that are now sort of making their way out of some of these companies and into the enterprise. And in fact, you're starting to see these technologies being used not just by the .com type of companies, but by the companies that represent how a lot of the enterprises are doing business, whether I'm oil and gas or whether I'm healthcare or whatnot. So there's a lot going on here. In fact, Hedvig as a company was founded by one of the gentlemen who built the system that ran Amazon with what was, I guess, arguably the beginning of the NoSQL movement with Dynamo, and then was drafted into Facebook, where he built Cassandra and open sourced that. So one of the things that he said was, I think this same kind of concept is going to need to be pervasive in the enterprise because they have some of the same challenges. The growth of data, the need to move faster, right? The need to control costs. And so with that, he started Hedvig as a company. And now we're out working with a lot of these types of organizations, not only these web scale providers or service providers or cloud providers, but actual sort of bread and butter businesses who are starting to look at, how do I deal with this kind of web scale technology, but in my own private data center? So what are some of the characteristics of it? And a lot of it's already been revealed here today in some of the discussions that have already gone on. What we're talking about is building technologies that are, on the one hand, built to be elastic. Now this is, I can scale out quickly, I can even scale back. Now the truth is, from a storage perspective, there's probably not a whole lot of scaling back that's going on because we put it in and then we keep putting more in and then we keep putting more in. But the idea is, can I scale out predictably with systems as I need to instead of having to pre-buy capacity for the next 3 to 5 years, which is kind of what we've become accustomed to in the enterprise mindset, right? I talk to, no offense, I was an EMC guy for 10 years, but EMC and I pre-buy what I think I'm going to need. Well, what if you could just buy and add as you go, and the software will assimilate and grow along with you in an elastic fashion? So that's part of the how the technology or the mindset is in developing this stuff. It's also, as Chris was pointing out, built to run on commodity x86 hardware. You pull the bezel from most storage arrays today, and you're going to find this stuff on the inside, right? But this is the characteristics of Webscale IT. We want to be able to have white boxes, commodity nodes. Now, I will say this, that hardware does still matter, and I think you guys are rightly pointing this out, that you can't put crap boxes underneath the software, otherwise you get crap, right? And so we are firm believers in putting the right kind of stuff in, the right kind of gear, the right number of drives, using SSDs, all that kind of stuff. What we like to say is that the quality of the components, like the specs themselves, are going to help deliver the kind of performance you need. And then in this case, in these Webscale IT shops, the quantity helps determine some of your availability. And part of that is because it's built to survive any kind of failures that may happen on a node or a drive or 10 nodes or 10 drives, because we are growing so fast that we can't have one system take down the entire system, right? So we have the expectation of hardware failure. Drives will fail, servers will fail, but the system needs to keep going. And so this is an aspect that is making its way now into the storage universe of what we call software-defined storage. One of my favorite mental pictures, and I haven't seen it online, I've been trying to find one, but apparently in these big web-scale data centers, sort of like this, you'll have a shopping cart where they're just going and looking for failed drives and components that have the lights turned on, and they just throw them in, and then they take them to the shredder or whatnot. So it is, I've heard it mentioned several times today, about cattle and pets. We're in this mode now where we want to really treat our boxes more like cattle, something that's, I'm not going to go nurse it back to health like I might my cat or my dog. I'm not going to rush down to the data center in the middle of the night to try and fix things. It's just going to break, the system auto-adjusts, auto-heals, and then I go through at some other opportune time and I pull the components out and we replace them, and on we go. And so this is part of the aspect of this scale-out IT architecture, if you will. It's built for automation. So I don't know if he's not in the room, is he? His thing was, I don't even want to think about the measure or the LUN or whatnot. I just want to be able to store it. I just want you to give me something. I don't want to have to push buttons to actually create the storage. Just create it and give it to me. So a lot of these systems are built to do that, right? To be able to just add and grow and extend capacity when necessary. And part of what we're doing at Hedvig, for instance, in like a Docker environment, is when you compose that Docker container for the very first time, you can request a volume that gets auto-created. There's not even an admin involved in that storage volume creation process. It's much more automated. It's also built for change. So part of what these companies try to do is out-innovate one another. And it's hard to do that when you're in a hardware-defined world that's very static, that's very hard to change, that's very hard to zig and zag, we like to say, right? You need to be able to create new things and roll them out very quickly. It's really like a DevOps world these days, right, where we want to be able to have the latest innovation, or maybe it's the latest patch, the latest version, and be able to push that out. So these types of systems are built to adapt and to change very quickly. And that's kind of where this whole software-defined concept is starting to take fire, because now it's much more about the fast beating the slow than it is about the big beating the small in terms of businesses. It used to be if you had enough resources to throw at the problem, you were going to win. Now you just have to be faster than the others. So let's take this over into the and built to reduce cost, which we covered. Let's take this over into this kind of software-defined world. And I just wanted to highlight, and I don't know how many folks are familiar. Anyone, EMC guys, I think would know this. Anyone familiar with the construct overall of the components in a software-defined? I just want to go through some of those, yeah. Kind of our perspective on sort of what goes into it. So if you're thinking about getting into this world, sort of at a high level, what are the things that you're going to install? Well, on the one hand, there's some concept of a storage software. Now, whether that's installing in a hypervisor environment or on bare metal, it is sort of the brains of the operation, the intelligence that knows how to store things, the intelligence that knows how to track where it's stored at, the intelligence that knows how to replicate data across systems and across even locations. And so typically there's something like that that you're going to install. It's also the brains in the sense that it will give you your features, like deduplication, like compression, like whether you want to use all flash or not all flash. Those kind of things are part of that piece that loads onto these commodity servers and then scales out from there. And with that software, as you add nodes to the system, you can simply grow and it will scale out along with you with very, very minimal manual intervention. The idea is to be able to aggregate and assimilate new nodes and grow very elastically over time. We have a customer that is using us on the back end of their backup application. And what they like about what they can do now with this system is as they start to get more data out of the field, they're a mining company, as they get more data out of the field that's being stored that they have to back up, over time they can go get a commodity node, put it in the system. They actually happen to be using Cisco UCS underneath our software and are leveraging the benefits of that kind of standard architecture and the ability to grow out automatically. Now typically there's also some sort of access layer or access software. And we talked about it at lunch, right? You called it a gateway, we call it a proxy, sometimes they call it an agent. It's this thing that knows how to direct you down into this now software-defined storage infrastructure. Northbound, it's speaking things like industry standard protocols that you need to deal with, things like iSCSI, things like NFS, right? And then southbound, it's able to speak into this storage cluster and send the data down for writing and read the data back for reading, right? Now, depending on who it's coming from, it may just only be doing that, but it may also be doing other advanced features, things like client-side deduplication, where the data is deduped before it gets sent across the network. Or it may be taking advantage of local SSDs to do read caching for your maximum sort of IOPS by leveraging flash resources right next to your application. Right? And the same way that can then scale out and give you access down into this software-defined storage cluster, this software running on commodity nodes. Now we call this hyperscale when you have this sort of two layers. You have your app host tier and then you have your storage tier beneath it. One of the things that was mentioned is that then sometimes you may want to run these things co-resident with one another, meaning I want my application to be right next to the data that I'm storing with this software-defined approach. And we call that basically hyperconverged. And I know that's a real hot term these days, but it's the idea that I can also have the same web scale characteristic in my storage environment, but also have my apps running right there next to the storage. So let's take a quick look at the day in the life of how this kind of concept, this software-defined or this distributed approach works. Now, typically what you'll do is either from an admin perspective, depending on how you're going about this, you will provision some sort of commodity nodes, and you may grow those nodes over time, right? And on there, we've loaded our software. And then, as needed, you will create and present virtual disks up to that application tier. At Hedvig, we have a user interface where you can select, I need 100 gigabyte block-based storage, LUN, if you will. And I want it to be deduplicated. I want it to be replicated 3 ways. And so you sort of provision this up. Or you can do this programmatically. You can have REST API calls being made down into the system so that that disk gets spun up, that virtual disk gets spun up for you automatically, right directly for the application. Earlier we talked about wanting to have this all be more automated. And some of our customers are actually doing that directly by integrating the two things together. So we present that up to the application tier. And that as these applications start to write, that data gets written down into the cluster. And it's not just stored on one server, but that data is actually, depending on its size and construct, will be broken up and distributed across these nodes in the cluster. And typically, for us at Hedvig, we do replication of that data. We don't do RAID, but you can think of it as almost like a software-based RAID, where you're taking replicas and making sure that there is redundancy, with the default typically being 3, right? And it's replicated across all those nodes, and then over time, the software in the background will be balancing, auto-tiering, depending on the activity in and around that data, and having that data being, for instance, if it's highly used, it's going to be sitting up into a flash tier, right? And so that's automatically going to be the faster for you. If it's not being used, and by the way, we're tracking all these things with a very rich metadata engine. If it's not being used very much, it's probably going to be sitting down on hard disk and just kind of be happily living there, right? And in addition to being able to distribute this data across nodes and across racks, you can also replicate that data across data centers, which might include a cloud. And how we achieve this effectively is because we're software, that software can install on your own commodity nodes in one data center or another data center. That software can load in Amazon's data center. That software can load in Azure data center. And all of this can be managed as one sort of single logical storage system. Now, the cloud nodes might be what? A little bit slower, more latency involved in getting there, but that can be part of the entire system so that you have this archive tier that's sitting up inside of a cloud. And in the case of Hedvig, we can provision block, file, and object depending on what your application needs. And all of that essentially lives inside the system, again, as a virtual disk. Now, what about for reads? And this is always a big question. Where's my data coming from? Well, that data reads are going to be coming from any nodes that may have copies of that data. Now, you may have been getting it from node A yesterday, but maybe node A had a problem, so you're going to get it from node B. And that's a part of that metadata engine that gets ran across all the different nodes, being able to be intelligently directing you to where copies of that data are. Now, we've had a customer recently test multi-data center deployment where they took down an entire data center and were able to kind of resume operations in another data center. Again, being able to run and have the applications now pulling from that data that's running in a secondary data center. And in the case of Hedvig, we have rich caching algorithms that are either happening in the storage tier or even at that application tier. So some of those reads may never even be going across a network and just be happening directly where the application lives. Now, how do we deal with failure? So part of what, again, happens automatically in these web scale systems is that when something fails, the system recognizes that this is now a problematic drive or this node is now no longer contactable and will make sure that your policies are in force. And by that, it recognizes that one of the copies of data is gone. We need to immediately recreate and heal that data onto another healthy node in the system. And again, this was designed by the folks running these web scale data centers so that at any given time, you never have to sort of try and go nurse a box back to health in order to save your data. It will happen automatically in the background. And then again, if a client is down or if a node is down or if a site is down, we can redirect that data to another healthy copy of that data. So part of the abstract for this this session was why is it, it's going to be in your future. So why is it going to be in your future? And this almost mimics, Chris, what your slide said just a little bit earlier. One is that data is going to continue to grow, but the money you have to spend on your storage probably isn't going to be growing quite as fast. So how do you deal with that complex problem? How do you deal with the fact that you need to save a lot more data than you have in the past? And it seems to be a never-ending problem. At the end of the day, too, part of what we've recognized at Hedvig is that one of the big complaints that customers have today is that it takes too long to provision storage. And if you're trying to roll out things faster, or if you have constituents in your company that need a new bucket of storage and you can't get it to them for 2 days, that's going to be unacceptable to them. And so part of this phenomenon of software-defined, of web scale, is about trying to make you more agile with provisioning. And in this case, provisioning storage can be very much AWS-like, so that you're sort of taking you're abstracting a lot of this feature function stuff that you would normally have to deal with on a traditional array and just saying simply, give me a virtual disk, and you have it within seconds. And a part of that responding quickly is really just about keeping your business up and running, right? You have to be able to keep moving, keep innovating. And we firmly believe that software-defined gives you that opportunity to be much more nimble and faster on your feet so that your business is prosperous. So in the last couple minutes, let me just tell you some of the ways that we see our customers getting started. One of the recommendations here is not that you go rip out everything that you have today and start doing things on commodity nodes and so on. There's a couple ways you can try it out or roll it out. And in some cases, some folks in an enterprise data center are starting with some traditional workloads, maybe some of the lower risk workloads, right? I'm using this new way of doing storage at the back end of my Veeam software, at the back end of my net backup software. And I'm using it to save my backup data across multiple locations, right? That might be one of the ways that works for you to just try out this new software-defined approach. Others are going full on into the VMware world and underpinning their virtualized their hypervisor environments with the technology. And yet others, as we know, have been wildly successful at doing VDI type deployments in a hyperconverged where I'm putting compute right next to my storage. Now, on the other hand, this is sort of a one type of slice of buyer. Maybe you're the kind of company that's already looking at the world of cloud. So you're trying to do this kind of approach for something more like an OpenStack environment. And we see, I think Gartner calls this bimodal IT. We see some folks saying, I'm not going to mess with the stuff that's running right now. I'm not going to mess with my system of record. What I'm going to do is I'm going to build a parallel universe that is cloud. And so we have customers that are starting out doing this either in a test dev environment that they call a cloud, rolling it into production, using things like OpenStack and Docker, doing things like NoSQL databases and so on. And others are using this to underpin things like their big data environments. So now I'm getting into this Internet of Things world, and I've got to store all this data somewhere. So that may be how you get started, is by building something that's more, I guess I would call it the modern workloads, the things that we were talking about this morning. So on the one hand, you might want to do this because you're under the gun for your budget and you're trying to save some dollars in terms of the infrastructure. On the other hand, you just may be all about moving faster and getting there much more quickly with your storage infrastructure. And so you can get started either one of these ways. So just a couple slides about Hedvig. You've probably already got it from where I've been talking today already. We provide software, loads on commodity hardware. Our founder has experience building these types of systems, and we pride ourselves on being able to provide a full-featured storage solution that is elastic, that is easy to use in the sense that when you provision storage, it's very fast. You can do it either just by clicking a few buttons or by doing it programmatically, very flexible. We support all the compute environments that you may have, things like VMware, KVM, it might be OpenStack environment, Mirantis, and so on. And we provide a very granular provisioning capability in the sense that that virtual disk I was talking about, you can give it its own personality. It might be that you want a block disk that does no dedupe, and you want it to all be residing on flash media. Well, you can define it that way and hand that off to your application. You may be doing something more along the lines of archiving, and you want an object-based disk that has deduplication and compression on, that's replicated across all these nodes. You can do that as well, right? And so this kind of granularity is very unique to Hedvig. And then last but not least, the ability to set up now a truly hybrid environment, multi-data center, including the cloud, and have that all sort of working together underneath your application environment. And that's a little bit about what we do and who we are. So I would invite you, if you're into this kind of world of exploring the software-definedness of it all, feel free to reach out to us. We would love to work with you, show you the software and whatnot. But it's a brave new world, and I think the folks at all of these web-scale companies, these hyperscale companies, have sort of shown us new ways to skin the cat. And I invite you to sort of join with that and look for ways that you can actually start to use and deploy the technology. So with that, I just say thank you. Any questions? Nick, come on, no questions?
I know. Over there.
Yeah.
I'm always good for
Yeah.
I'm sure how to tee this one up, but so talking to other software-defined technologies and such, sometimes people seem to make a big deal out of running in user space.
Right.
Versus, I guess, code space
Yeah.
or whatever. I'm not sure how, so is that a big deal, or is that covering up some other deficiency, or what's the pro or con of running in user space?
Good question. And I think some of that access software that I talked about, for us runs in user space. And one of the benefits there, I think, is that when you're in the kernel, there's a lot more, let's say we're in the ESX kernel or whatever. As soon as VMware changes things, we have a lot more to keep up with and more development to keep up with. It becomes harder to support the different types of environments that you may want to run in. And so sometimes being able to run in user space means that you can have a much more common way to run that software without all of the heavy kind of customization every time a kernel changes from one of the vendors. That's the kind of thinking that we have in terms of having that, what we call the proxy run in user space.
Is there disadvantages to running in user space versus kernel?
Yeah.
I mean, what would the guys that run in kernel space say to that?
They would say there's more latency. You're not as tightly integrated with it. Chris? Yeah.
VMware never let storage vendors get into the kernel of ESX until vSync came along, and they're the only ones that can do it. There's probably a reason for that. Well, kind of. It's kind of a gray area. Yeah.
For us, being in user space means we're much more portable across different platforms. So we can support KVM and Zen Server and all that much more easily, and bare metal environments and so on. So it's a good question. No one has ever asked me that question. Okay, thank you guys, appreciate it.